All right. For starters, let's look at the final exam. Let's see. So the official time for our final exam is 7:30 a.m. Tuesday. But we're okay. We're gonna move it to 4 a.m. and it's it's like even
Yeah.
well, that means you don't actually have to go to sleep the night before. You just cram right up to it.
Yeah.
Okay, so official time is 7:30 a.m. What did it say, Tuesday? So what I'm gonna do is I will put the exam up on Blackboard. It'll be up by Monday morning. I just need you to do it by midnight on Friday. The exam will be designed to take about an hour. I'll give you 3 hours on the time limit. I don't want time to be a thing. So you can decide how much time you want to set aside. If you're the type student that typically zips through exams, set aside whatever you want. Otherwise, typically the final exam would be a 2-hour time period. That should give you plenty of time to check your work and things like that. If you want to use the full, like I said, I'll probably do 3 hours on there as the time, just so there's no time stress. You could have the time if you want. It is closed book, closed note, closed neighbor, should be your own work that you're turning in. Let's see. You can use a calculator for any kind of conversion questions, things like that. Is there a question? Okay. But what I'll guarantee is that I will be live online and on Slack as well as Zoom on Tuesday morning, starting at 7:30 until 9:30, 9:20, something like that. If you want to plan on taking it during that time period, you would then be guaranteed to be able to ask any questions, things like that. Otherwise, I typically on Slack, I get questions pretty quickly, but there would be a guarantee that you would have access to me. So if you anticipate having to ask questions during the exam, you can certainly take it during the scheduled time period, and I'll make sure that I'm available. Okay, questions about the logistics of the exam. We'll talk about what might be on there here shortly, but any questions about how the exam is going to work, when you can take it, yada, yada, yada? Go ahead. Well, okay, so the way it works is if you do better on the final exam than you did on the midterm, I'll replace your midterm exam grade with whatever you got on the final. Yep, so if you had an 80 on the midterm and you got a 90 on the final, you'll have a 90 and a 90. Yeah. Yep. But all in one sitting. You can't like do piecemeal. So decide the amount of time you're going to set aside, find a nice quiet place, whatever, with not helpers. And the thing is that because of the nature of the way I grade the exams, I grade them one question at a time with names turned off. It's usually pretty obvious when when you've been working in teams. So it really doesn't do you very much good is the situation. That's why I prefer Blackboard, is it lets me grade one question at a time with no names on it. Because even if you have paper exams, you can try to say, I'm not going to look at the name, but if I had somebody, like Danny or something, I don't like the guy. So it's like, well, right off the bat, you're down 30%, regardless of what answers you put on there, is what it comes down to. So it ends up being that if I can grade it completely anonymously and I can grade it one question at a time, then I can apply, fair grading across the same question and make sure one person doesn't get a 7 out of 10 for the same answer that somebody else got an 8 out of 10 for, and that kind of stuff. Okay, so that's the scoop on the final. Let me kind of go through. Let me put a couple things here. So there'll be 10 questions, just like the midterm. There'll be at least one conversion question. That'll be either converting from one base to another base or converting from a size to another size or a time. You know, like for instance, I could ask you, you know, how long would it take for you to download a 3 GB file over a 100 megabit per second internet connection, something like that. You should be able to flip flop between bits and bytes and that kind of stuff. So there'll be at least one of those questions. I might even say probably two. Because this is the class when I first introduced those things, so I would say there's a decent likelihood of there being two conversion questions. So as long as you covered your butt with those, I mean, that's 20% of your grade is just from conversion questions. So make sure you focus on those. There will be programming questions where you'll have to either write some lines of code or write a function. So things to pay extra attention to is the specific words I use. If I say, you know, write the code necessary to accomplish a certain thing, I'm not asking for a function or anything. I'm just asking for to write the 2 or 3, 4 lines of code, whatever I asked you to solve. If I say write a function that takes a certain thing as a parameter and does something, then I'm expecting you to write a function. Part of that question is for you to show me that you understand what a function is and you're able to write a function. All right. Pay close attention to those questions and whether I'm asking you to display something or I'm asking you to return a value. So again, that's part of what I'm testing on that question is, do you understand the difference between a function displaying a value versus returning a value? These are things that you should, you know, understand. So focus on those couple of things. It's not just write random code that solves a problem. Also, when I say write a function, you don't have to give me the main method where you call that function unless I specify that. I'm asking just for the function. Okay, so return type, name of the function, parameters, then the logic. All right, that's all I'm asking for on that that question. Okay. What I should do is I should put have a random question that just has like some word that I put on Slack between now and the exam and see how many people actually read Slack and put it up there. Really is shocking to me the number of folks that don't look at Slack. Less about the email, but yeah, Slack is like you could put on notifications. It's like it's not, it shouldn't be that hard. So let's see. I mean, the emphasis on the exam will be things since the midterm, but programming builds on everything else. So, you know, the idea is that, you know, you're going to still have to know how to define variables, ask questions, you know, through conditionals, write loops, write functions. There will definitely be object-oriented stuff on their classes. So you'll probably have to write a class to do something. Another thing to pay attention to is I might ask you to write a header file for something as opposed to actual implementation. So you should understand the difference between a header file and the implementation file. So if I ask you to create a class, but only give me the header file for it, you don't have to write any of the logic. I want you to show me, here's the header file, here's my fields, here's my constructor, here's the couple of methods that I may have asked for, but the method definitions of those, not necessarily the content of the methods. If I ask you, if I say, given this header file, implement the display method or something like that, then you should understand that this is where you're actually teaching it what to do when somebody were to call the display method, as opposed to the header file. So know the difference between a header file and the CPP file. Okay. So there's all your practice and number conversion stuff. You might spend a couple of extra minutes just looking at the shortcut type things for converting values. So going from a, like base 10 number to a base 6 number, there isn't really a shortcut. But remember, binary, octal, and hexadecimal, there's some convenient shortcuts going between those. You never have to use the shortcut, but it might save you some time, and you never know if I'm going to ask a question that would greatly benefit you if you knew the shortcut. Remember the 3 bits for octal, 4 bits for hexadecimal. So it would be handy if you knew that. That's really these slides right here. Definitely be able to deal with modulo, taking the remainder of integer division. There's probably a decent chance I'll use something involving that on one of the functions. Like something with a value that's evenly divisible by 4 or 5 or 6 or whatever it is, or even numbers or odd numbers, that kind of stuff. Be able to detect those with modulus. There's an example of data sizes and things like that for the other conversion question. I won't ask anything dealing with like resolution and number of bits and that kind of stuff. So it'll strictly be, gigabytes to bits or, that kind of stuff, or time if you have a certain speed internet connection or something like that. So you should understand that 100 megabits per second means that you have the capability of downloading 100 megabits every single second. I might ask you, how long would it take you to download a 3 gigabyte file? Gigabyte with the big B. I wouldn't worry about any of the history stuff. Certainly understand that the difference between a procedural language and an object-oriented language, especially since the midterm, we've been talking about objects. So there'll be more of a focus on that, which means that you should definitely understand this keyword. Definitely understand the concept of a constructor. Understand that classes are collections of fields, constructors, and methods. So the nature of a class, and this slide right here talks about the difference between your procedural older programming languages and our more modern object-oriented programming languages. Nothing with bitwise operators, just like the midterm. That was more trivia stuff. It's stuff everybody in here, or a high percentage, you are probably taking 325 next semester. So that's something we talk about in there. I'm not sure who's going to teach that yet. It'll either be me or Blade, but one of us will teach it. Be able to write loops. Definitely understand variable scope. There could be a question on there dealing with understanding that variables resolve to their most local definition. So I could show you some code, and it could be that code has 2 different variables named int a or something like that. And I might ask you, what will this code display? And you would have to show me that you understand the difference between variable scope is, if a variable is being displayed in a local scope, what value will actually display versus there possibly being a more global version of that variable. Mentioned this a little bit ago, the difference between a function that displays a value or just does something versus a function that returns a value. Make sure you're very clear on those 2 things, because I will likely on the exam have something dealing with you understanding that distinct difference. If I say write a function that returns something, I expect it to return something, and displaying it is going to show me that you didn't understand what it meant for a function to return something. Something in this transition, primitive types versus object types. Primitive types like our int, char, are those guys that can only hold a value. Our object types can hold values through fields and then potentially do other stuff through methods. There will definitely be something on there dealing with a string, manipulating a string, reversing a string, removing spaces from a string, counting spaces in a string, something like that. So be able to loop through and do things with strings. Same thing with arrays. There will not be a question on there that will ask you. So like, for instance, there won't be any question that requires you to use that malloc function, the memory allocate function. I mean, I want you to really understand the idea of the memory underneath the hood there, but I also don't want to like purposely trick you on the exam because I realize it's not the friendliest syntax in the world. I will probably, if I have you work with an array, I will probably say, here is an array. Maybe I say, here's a function that, or write a function that takes an array and the number of elements in the array, those two parameters, do something with it. So that the presumption would be that the array had already been created and filled with stuff. And now you need to do something to the array, write a loop that goes through all the buckets of it, something like that. Certainly understand the concept of contiguous memory. Memory right next to each other. Definitely understand pointers. There'll be something on there dealing with, well, plenty of things on there dealing with your understanding of pointers. So here's that variable scope stuff I was talking about. So understanding what's on this slide would be very beneficial. Definitely understand the new keyword in the context of creating instances of objects. Definitely understand the difference between pass by value versus pass by address. What the benefits, what the benefit is of passing by value versus passing by address, that kind of stuff. So again, objects are collections of, it's a class, collection of fields, constructors, and methods. Know what those are, be able to work with them. I won't ask you anything dealing with structs. And that mostly has to do with modern day programmers rarely deal with structs. It's not so much that they're not important, and it's not so much that they're overly difficult. A class kind of is like a struct that just doesn't have, but that adds some additional abilities with some caveats, because structs are passed by value by default. But the point is that if you go into industry today and you become a Java or a C# programmer, there's a decent chance you might spend your entire career and never write a struct one time. It's not that they're difficult. It's just we have more modern constructs like classes that you'll typically be using on a daily basis. But if you're a C or C++ programmer, or you go in, you're maintaining code from there, you're going to very likely be dealing with structs all the time, because chances are you're managing code that was created 40 years ago or something like that, that use structs left and right. So it's not like these are a waste of time, but I won't be testing you on it on the exam. The focus will be on classes as opposed to structs. Definitely understand that this keyword, it's going to be, there'll be at least one question that makes you show me that you understand what the this keyword is, how it works, why it exists, that kind of stuff. Again, header files, pay close attention what I'm asking you to do in a question. If I remember back to the previous exam, I would ask you to do one thing, and some people gave me 3 times what I actually asked you to do, which then gave you the perception that the exam was super long or something like that, when I was like, I just wanted one line of code or something like that. So if I ask you to give me the header file, I'm asking just for the setup, the blueprint of it, not the implementation. Definitely understand the difference between public and private and what connotation that ends up having with getters and setters. We have private fields. Private fields are only accessible inside the class. Public fields are accessible everywhere. So that's the slide, gaining public access to private fields through our getters. You won't have to worry about like this historical accessor methods versus getters and mutators versus setters. I don't care what you call them. I won't ask you a vocabulary term of, you know, define a getter or something. I might. Those are pretty commonly the terms now, getters and setters, but it's really a function that allows you to access a private member. You can call it whatever you want. It doesn't matter if you gave it the getter nickname. It's just a plain Jane function, nothing special about it. All right, so now we got into some of our examples of working with classes. Okay, so now we're kind of into our more recent thing. I mean, I'm not going to ask you questions specific to the projects we've been working on in class, but you should certainly, if I say, create a class that represents, you know, an automobile or something like that, you know, you should be able to give me the header file of, for example, or if I ask for the implementation and I give you the header file as a starting point. Oh, hold on, I think somebody's in the waiting room. And I ask for something like the implementation, you know, you should be able to go in and say, okay, well, an automobile maybe has a color and a number of wheels or something like that. Those are the couple of fields. You should be able to write an appropriate constructor for that takes in a color and a number of wheels and sets the those fields equal to it. Maybe write a display method that displays that guy's color and number of wheels, you know, that type of thing. And certainly on an exam, I'm not going to, the complexity of what I'll be asking you to do won't be at the same level as what we've been doing in our homework assignments just because of time constraints. Okay. So I think that pretty much covers the stuff that I'm going to ask on the exam. So any questions, anything you want me to review? Go ahead. Yep.
Do you have any advice on how to study for the program questions?
I guess not necessarily specific advice. I mean, I like the idea of kind of coming up with little kind of puzzle problems yourself. The questions I tend to like to ask on exams deal with take in a couple of integers, do something to them. Take in an array and do something with that array. Sum up all the numbers, reverse the array, something like that. Take in a string and do something to that string, or build a new string that's that string in reverse or with the spaces removed, that kind of stuff. So, you know, because on an exam, just given the time constraints, I end up asking more like puzzle questions like that. So if you were going to kind of prepare for it and wanted to just give yourself some little challenge exercises, you know, you might say, I'm going to write write some functions that take 1, 2, or 3 integers in as parameters and just give yourself a little challenges of doing something with those integers. Or write something, it takes a string in and give yourself a couple of challenges of do something to that string. Just use your imagination of, you know, maybe you're going to remove all the E's from the string or something like that. Just kind of drill that idea of taking in parameters of a couple different data types, maybe int, string, arrays, that probably covers it, maybe a char, but chars, ints, kind of the same thing. Writing some loops that manipulate them, or writing some conditionals that ask questions about them, that kind of stuff. All right, what else? Anything you want me to review or anything before we go and solve the problem for today? Go ahead. Yep, pass by value versus pass by reference. So when you have a function and you pass a parameter to that function. So for example, integers by default are passed by value. So if we have a function, you pass an integer to that function and you make a change to that integer inside that function, that change will not be recognized outside the function because you got a copy of that value. So passing by value means you are sending a copy of the value as a parameter. So any changes that happen to that copy will not impact the original. Pass by reference is when you're sending a pointer into a function. And that means that you're not sending a copy, you're sending it the actual address where that function, the inside of that function can find the original value up in memory. So any changes it makes to that original value will have side effect. Those will be permanent changes. Okay, so pass by value means a copy is getting sent in. It will not have side effect if you make changes to it. Pass by reference or pass by address, you can kind of use those two phrases interchangeably. Means you're giving it the address where the original lives. So any changes you make to the original will be felt, will be noticed outside of there. All objects. Yeah, I mean, we create like a player pointer P. It's a address, right? It's a player pointer. So yeah, anytime you're passing a pointer in, you're passing it the address of something. Arrays. Similarly, if you want to have an integer array, it's int star. It's an integer pointer, points to the base address of the array. The base address, the contiguous memory. So you're sending a pointer in. So basically anything that if you were to print it out, you would get a memory address. If you're passing that parameter into a function, that's being passed by reference and changes will be permanent. Anything else? Going once, going twice. Okay, so let's look at our final assignment that we did for today. Let's see where we left off here. All right, so we have 4 rooms from our picture. Let me get my picture loaded up here. Is this even the? Yeah, here it is. There we go. So right now I have these rooms showing up. I have those rooms created. And then what I did is I created exits between all those rooms. So from entrance to hall 1, we have an exit to the south that leads towards the entrance. We have an exit to the north that leads towards hall 1. And these constructors for exit, they let the rooms know about the exit. So a room knows about all the exits that are inside of it and adds it to its array of exits. All right, then we created a player and we went ahead and added a player to a room. So we added them to the entrance and we told the player to look around. So if we just run it right here, we see that the player notices that he is in the entrance with an obvious exit to the north. Okay. And the player is here. He sees himself in the room. All right. So now what we want to be able to do for the assignment was to allow the player to, well, build a move function that will remove the player from a certain room and put him into another room. So that's what this guy right here was going to do. And then the idea would be is after we move, the player should be able to look again and see they are now in a new room. You can put that inside the move function if you want, or you can just put it outside of it. So player looks around, sees themselves in the entrance. They move to the north, look around, they see themselves in hall 1. That's what we wanted to accomplish, right? Okay. So let's see. Where did we start with move? So in player, here's our move function. Oh, I mentioned a player should look around after they arrive at their new destination. So technically, and I don't care if you did it inside there or outside, but technically the player won't have to look a second time because I told you to put the look inside of the move method, but I don't really care. It's fine either way. Okay. So the idea is we go to a player. The move method is going to take in a direction. So the player knows about the current room he's in, right? And he wants to go to a new room. That is the room in this direction. Now, rooms have a collection of exits. So if I go into room and I teach a room how to give me a destination room given the direction I want to go, a room should be able to go through its exits and find that destination room given a direction. So let's go ahead and write this. So inside of room, I'm going to have a function that's going to return a room pointer. Maybe get room given direction. This guy will take a string direction in as a parameter. So that's my header file. So I've just prototyped it. Now I'm going to go and implement that guy. All right. So from a room's perspective, a room has a collection of exits, right? Called the exits. And they know how many exits they have as well. It's called number of exits. So if I'm asking a room to give me the room that this direction leads towards, all right, the room is going to have to go through all of his exits and ask each exit, hey, do you have a room in this direction? All right, so inside of room here, we're going to have a loop. For I is equal to 0, I is less than this number of exits, I plus plus. All right, and we want to get the current exit we're looking at. So I'll just go ahead and give myself an exit pointer, cur exit, and we'll say cur exit is equal to this, the exits at bucket I. All right, so from a room's perspective, I'm holding on to an exit. Now, I don't know if this exit, in my initial case here, where this room only has one exit, I do happen to know that this exit's the guy that's going to have my direction. But if I was in hall 1, this guy has 3 different exits. If I'm looking for the south exit, and I'm currently looking at that guy, he's not going to have that direction for me, right? So I need to go through and I got to say, look, I'm trying to go to the south. Exit, I'm trying to go to the south. Do you have a room in that direction for me? If yes, give me the room. And I'm going to remove the player from the current room, put him into that room, tell the player to look around, everything's great. If you don't, I'm going to go check my next exit, right? So for current exit, we need to be able to ask an exit, do you have a room in this direction? And we could do this in a couple of steps. We could teach an exit to say, you know, to return true or false, do you have a room in this direction? Or we could just ask it for a room given a direction. And if it gives us nothingness, it gives us a null value, then we could say, oh, you didn't have an answer for me, so I'm going to go try the next exit. So let's go ahead and we're going to have this guy return a room pointer. Get room given direction. So this is me asking a room, do you have a room that, I'm sorry, yeah, do you have, this is me asking an exit. Do you have a room leading towards a certain direction? So we'll go ahead and implement this guy. So I'm just going to ask some questions. I'm going to say, if this direction A is equal to the direction you passed in, then I'll go ahead and return this room A. Else if this direction B is equivalent to the direction you asked for, I'll go ahead and return this room B. Okay, so if you asked for a direction that's equal to the direction leading to room A, I'll go ahead and give you room A. Otherwise, if you asked for a direction leading in the direction to room B, I'll give you room B. Otherwise, I'm going to return nothingness. Okay, I didn't find a room for you. I don't have that direction. So we'll go back into room here. We're inside of get room given direction. I've grabbed a current exit. So I'm going to say room pointer. We'll just throw it inside of something called answer. So we'll say answer is equal to her exit. So I'm going to ask the current exit I'm looking through it before we're looking at, right? I'm going through my loop of all my exits from a room's perspective. I'm going to say, okay, I have an exit. He's called cur exit. I'm going to say, hey, do you have a room leading in direction? So given the direction I'm trying to head, does the current exit have a room in that direction? So if answer is not equal to null, if I got a real answer back, then I'm done. I found my room. So I'll return answer. And remember, return makes a function immediately end. If answer was equal to null, I have not found my room yet. I need to loop back up and try the next exit and ask him if he has a room in that direction. Make sense? So now from a player's perspective, inside of move, a player is going to ask his current room, so we'll maybe call the answer new destination. He'll ask his current room, get room given direction, and he'll pass it the direction. So the player is going to try to move in a certain direction. How does he move in that certain direction? Well, he needs to start off by discovering the room that's in that direction. So we'll ask the room I'm currently in to get the room given a direction and pass him the direction. So in here, the player's trying to move to the north. So if I'm standing in this room right now here, when the player first starts his starts in the dungeon, he's in the entrance. From this room, it's going to loop through all of the exits in this room, and there's only one. You can say, I'm trying to go to the north. Do you have a room to the north? He does, so he expects it to return the room pointer to hall 1, right? And that's what's going to come out of this right here. In our example we're looking at right now, new destination will be a pointer that points to the same place as hall 1 points to. Because hall 1 is a room associated with this exit that is in the direction to the north. So now I have a pointer to hall 1. The player is still in entrance. So now we need to get player out of entrance and put him into hall 1. That will make him walk through the door, right? Now, a room, remember, keeps track of a player. But we can also ask a room, well, a room has the ability to add a player to it, but we also have the ability to ask a room to remove a player from it. And this does give us the player pointer, but inside of player, we don't need that player pointer because we already know about ourselves. And I'll kind of show you what I mean by that. So I can say player pointer temp is equal to this current room remove player. Okay, so a room, if we call remove player, he goes through and he grabs the player it's going to return, sets the room's player to null. There's no longer a player in this room, and then he returns that player. So inside here, temp and this hold the same address. Why? Because the player has talked to their current room and asked them to remove the player that's in that room, which happens to be this player. We just wrote remove player such that in case we wanted it, remove player will give us the player that it just removed. So we actually have two different ways of talking about ourselves right now. This particular player knows himself as this. He also knows himself as temp. Those pointers go to the exact same place. We didn't have to store this if we didn't want to, just because remove player returns a player. Since I don't need that player right here, I can just choose not to store it. So after that line, we can say this player has been removed from the room they're currently in. Then we'll say new destination, add player, this. So the player found out where they're going, given the current direction. They asked the current room they're in to remove them, and then they asked the new room to add them. And remember, add player for a room sets this room's player, and then goes ahead and sets the player's room, current room, equal to this instance of room. All right, so moving for a player means find the room that I'm moving to, given the direction I'm trying to move, remove myself from my current room, add myself to the new room. And then the player can go ahead and look around. So we'll try to move to the north here. So we'll look at that here in a second. So he's originally in the entrance with an exit to the north. He moves to the north. Now he's in hall 1 with an exit to the south, the west, the east. All right, let me fix up this thing real quick. This is a function that we didn't return a value from. Room CPP 28. Get room. Okay, we're making the assumption here. We know, well, we're really error checking. We're making the assumption that this direction that we've sent to the room will eventually result in an actual room pointer. Okay, but if I said I want to go to the direction Woot, we know we don't have any exits in direction Woot. We're not going to find any destination rooms in direction Woot, which means that we'll never actually get to this line. So this for loop will end, we'll be done going through all our exits. So we could probably just return null. I didn't find a room for you that met your criteria. So now he won't give us that warning now. All right, go ahead. inside of this guy. This guy, did you not put that? What I have highlighted here. I mean, it's gonna be something with your syntax. All right, so we've now moved to the north once. I can now, let's say we want to move to the west. That should end up get us into hall 0, right, to the west. So we'll just test this a little bit further. So after we've moved to the north, we'll go ahead and move to the west. So there we are, going from entrance to hall 1, then we went to the west. Now we're in hall 0 with an exit back to the east. Seemingly we're able to wander around our dungeon, right? Okay, but we have to manually put in our moves. So what would be nice here is if we taught a player, well, if we continually ask the player, where do you want to go? And the player could type in the direction, it would then move in that direction, and then it would show you the new place. So maybe we add to player. Maybe it's just called a start method or something like that. So start takes no parameters. So this just kind of starts the engine on the player. So the player just starts asking you, where do you want to go? Where do you want to go? So on and so forth. We'll go ahead and implement that. All right, now one thing I want to point out before we go any farther here, I want you to kind of notice how we implemented the work for today. One thing hopefully you heard me saying is go back to main. A player tries to move. What does that do? Inside of move, the player asks his current room. Okay, so it's almost like there's this conversation between the objects that are involved here. Almost think about them as actors in a play. So the player is going to grab his current room and ask that room to give him a room in a certain direction. So now the player is waiting for a response from this other object. So all these objects are kind of working in cahoots to solve this problem. Okay, so in order for a player to move, the player asks his current room to give him a room in a direction. How does that room work? Get a room in a direction is going to involve that room looking at all of his exits and asking each one of his exits to give him a room in that direction. And if that exit was able to deliver, then the room says, I'm done. Here's the information the player asked me for. If he's not, he's going to go and check the next exit. From an exit's perspective, what does an exit do? Well, if I'm getting a room in a given direction, the exit just asks some questions about his variable. He said, well, is he trying to go in direction A? If yes, here's room A. Is he trying to go in direction B? If yes, here's room B. Otherwise, I don't have an answer for you. Here's nothingness. Try again. So this exit will report back to the guy that was talking to him, which was room, who will then ask about the answer he got from his exit. Did you give me an actual room destination? If yes, I'm done. I'll let the player, the guy who asked me, know. If not, I'll spin back up. I'll try the next exit. right? So the logic here involves, we have three different objects at play here. Look back at our picture. We have a player, a room, and an exit. So solving this problem involves those three objects working together to gain the information they need to accomplish the task. That's the concept of object-oriented programming, where we're trying to solve problems in a similar way to how we solve them in real life. Now, having said that, there's a little bit of strangeness here, right? So in real life, people might make fun of us if we sat in the room and said, room, I'm looking for an exit to the, whatever direction that was. What did you tell me that was? South. I'm looking for an exit to the south. You know, rather than using my eyes and looking over there, I just, you know, I'm real lazy. Just talk to the room and, you know, room, give me an exit to the south. It's like, I'll wait. And then the room goes and does his thing. And he finally, you know, I get the big red arrow pointing over there. And, you know, it says, there's your room. You know, there's your exit. It's like, okay, room, take me out of here. And then this other room, put me in there. That's a little bit weird how we operate in real life, correct? That's not how we, I mean, it's almost kind of kingly, right? That's kind of the way I wish life worked. That would be nice. Just people just carried me from room to room. Okay, but it is kind of the mentality when we're dealing with objects. We need these objects to sort of, you know, rely on each other to solve problems. Now, having said that, there isn't a great reason why we couldn't have had the player go ahead and look around the room. So the player could have asked the room, give me your exits. And that's the effective. So inside that move function for player, we could have brought a lot of that logic. And we could have had the player be operating off of a collection of exits. So I'm just looking around the room. Okay, I got an exit there. That's about it. Let's hope that's the direction I want to go. And then the player can say, okay, well, I'm going to now investigate these exits and see if we have one leading in the direction that we want to go. And at that point in time, that's when I would then remove myself from the current room and place myself in the next room. Make some sense? All right, so you can solve this problem in different ways, but in all of those circumstances, we are using those objects. So in real life, a human being might mostly rely on themselves, right? We use our eyes, we look around, we say, okay, what exits do I see in here? I see that one. Is that guy to the south? Yes, it is. Do I want to go to the south? Yes, I'll go ahead and remove myself from this room and put myself in that room by walking through that door. That would be the more natural way that we would solve it in real life, correct? But in an object-oriented sense, we can rely on these inanimate, normally inanimate objects to do some work for us. And that's kind of what we did here. So this isn't the only way you could have solved it, but this was a reasonable way of solving it because, hey, a room knows about his exit. So I might as well ask him to give me the exit in a certain direction. An exit knows about the rooms that it links. So we might as well, a room might as well ask his exits to tell him the room that's going in a certain direction. Make some sense? All right, so you could almost think about objects as like actors in a play, and each one of them has their own abilities. You don't necessarily need to think about a room being inanimate where a player has brains behind it, because as far as programming goes, these are all just objects. Okay, so questions about that kind of thing? Yep.
So I have
So you said if you're in hall 0 and you go to the west, it puts you back here? Well, then my guess is, well, first of all, it's clear you've done something wrong, right? Okay. My guess is whatever you named this direction, maybe it's a capital W for west instead of a lowercase w or something like that, or you're spelling it different, or there's a space afterwards. Something along those lines. If it's working for everything else, if you're in this room and you say, I want to go to the west, and it's not taking you here, you either didn't create this exit correctly, it's one possibility, or you had the directions misspelled or case sensitivity. Yep. Yep. And you're doing the, well, I mean, we just did 2 directions in a row.
No, but they're the same direction. You can have the new one.
I see what you're saying. I see what you're saying. Well, so here, I'll go ahead and add S120 into mine here. Next to hall 0 is S120. And then we're going to have another exit. That's going to go from hall 0 to the east, S120 to the west, right? So this player should be able to move west twice. This is what you were saying. We're stuck in hall 0. Hall 0. So when we add an exit here, so it has to be in how we're adding this exit. So from hall 0's perspective, we have an exit to the east, we have an exit to the west. I tell the player to move to the west a second time. The player goes in, tries to move. He's going to ask the current room he's in. To give a room and a destination. So that'll be the last one to pop up there. And then I'm going to print out S120 here. No, that guy doesn't have access to. So that's the address of S120 right here. That's what I printed up here, 7070. So when we asked the room for our destination here, we got this destination address. We went there. When we from hall 1, when we went to the west, we got this destination address. We went here. And then we did get the same destination address here going to the west. So hall 0 is to the east. S20 is to the west. That's the way that these things are written. That's correct. So this does say that we're going to the right place. The place our room found that's in a certain direction is to there. So the question is why? Oh, it's a great reason why. from hall zero's perspective, actually, hold on. If I'm in hall 0 and I'm asking for my exits, I was going to say this. Oh, yeah, there is great reason why. This exit right here and this exit right here, both are exits that hall 0 knows about, right? This guy has a link to the west leading here. This guy has a link to the west leading here. It's finding this west first. So really we need to say, give me a direction to the west that's not to me. Because this guy here has in my example right now, he has 2 exits. In our picture, he has 3. But 2 of those exits have a direction to the west. Only one of those is appropriate for where I really want to move, right? Okay, because the other one, we're getting this false positive. Sure, this guy here does have an exit to the west that should have only been exposed to this dude, but he technically has access to it in here. So in order to fix that, we would need to, when we ask a room to give us an exit to a certain location, we would then have to make sure that that exit wasn't that the destination wasn't the same room as we're currently standing in. So it should be a pretty quick fix. So right in here, we get our answer. So presumably this is the room that's to the west, but it happened to find the room first. We need to say, well, if the answer is not equal to null and answer is not equal to this, make sure that the destination room you just provided me isn't to me. Send me to a different place. Try again. So this should fix it up. So now we ended up in S120. Make sense? That's a good one. Again, a good thing to look at our objects, and we see that's why we were getting that behavior. It just so happened that the order in which we built these was that this exit was added to this room before this exit was added to that room. So as this room was looping through all of his exits, he stumbled upon this one, which did have something to the west before he stumbled upon this one. Yeah, we're asking an exit. Give me the room to your west. That exit he doesn't know who's asking for this, right? You just know somebody asked me to give him the room that's to my west. And this guy said, I got one of those. Here he is. Just happened to be the same room we're standing in. So, kind of one of those endless doors. So a little bit of logic and that we added to it, which is a good example of using and. It's like, look, if you gave me an answer, great, but I also want to make sure that that answer isn't me, isn't the room we're currently standing in, because that's not the west I'm looking for. I'm looking to leave this room. I want to go to a different room to the west. Keep trying. All right, that makes some sense. All right, so what we want to do is, instead of having to do this inside of player, we want to basically have an infinite loop, we can say, where we just keep asking, what direction do you want to go in? And then we read in that direction, and then we try to move in that direction. So we can say something like, while true, just an infinite loop, bad programming practice, but we'll just allow it to happen in this case here. Okay, so really we would probably do it until the user entered like quit or something like that. Okay, so while true, what direction do you want to go? We'll ask the user for a direction. We're going to have a string direction that we're going to read in. Does this guy have access to string? He does, because he has a name. So we'll go ahead and say CN direction. This move direction. Oh, and I need to the player start. And what we can actually do is actually have the player initially look inside of start. So before he starts doing this forever, he'll look around. All right, what direction you want to go? We'll go to the north. Now we're in the north. What direction you want to go? We'll go to the west. Now we're in the west. What direction you want to go? We'll go to the west. Now we're there. We can go back to the east. We can go back to the east. We can go to the east. So now we're in hall 2. We can go back to the west. We can go to the south. So now we're walking around our dungeon. And I'll take out that pointer I was printing out. Oh. Infinite loop, so that's why it says stop. So what we could do here is we could say while direction is not equal to quit or something like that, which then means we can't have a direction called quit. Where did I have that other print? Oh. All right, so we can go to the north. It has to be inside of look. Or inside a player somewhere. All right, so now we can go to the north, we can go to the west, we can go to the west, moving around. When I'm done, I can just hit quit. And we're done. Yeah, we didn't. It did get us out of there. Yeah, why didn't it display? Well, doesn't matter. Is it because CN left us at the end of that line? I typed in quit, cut up the direction, it was true, it was equal to quit. So this failed, we fell past it. See out goodbye Adele. What is that? It definitely exited us out. Program finished with exit code. No, because I mean, it's breaking out because of that Boolean. Direction is equal to quit. That's what I just read in. It's hitting this and it's falling past it, which is getting us right here. I don't have anything funky after this while loop. Let's go back out to main. What happens after this? So it's like the program is, this is my suspicion, but the program is ending before this actually gets put out to the screen. Well, that would work. It should, if I say return. Well, that's actually a good question. It shouldn't make a difference, in my view, between those two. If I take the return out. See, what I'm thinking here is the issue, which shouldn't be an issue since it's finishing, but maybe it's the way that their terminal works here. Printing stuff out, see out, is expensive. I think earlier in the semester, I kind of showed that where maybe I had a loop that went through 1,000,000 times or something like that, and I displayed versus like added, and it took a lot longer to display. So this guy takes time. And I'm thinking the program is actually ending before he actually gets around to displaying to the screen. So I don't know. Leave it at that. Move on with life. All right, so I'll put this code up so you have it to mess with if you want. No homework, obviously. So next thing you'll see is the exam up Monday morning. It'll be an announcement once it's up. And then get it done by Friday, and I'm around all next week. So questions, comments, concerns, bribes? Oh, yeah. So I put up on Slack last night for those of you most of you who don't look at Slack. I guess the Bible homework is labeled as being due by midnight tomorrow. I'll let you turn it in by next Friday. So if you have projects you're finishing up for the semester, that's fine. I'll do all my grading over next weekend. All right. So I'll see you when I see you. Well, I'll see most of you next semester in at least one class, maybe two. Can you imagine the joy of that much homework? Having two classes? It's like an holy dream. The programming in 325 is a different kind of programming. The assignments aren't like multiple hour type things.
Yeah, I mean, it's not like you up till 3 a.m. anyway.
Yeah.
Like smaller snippets then?
It's just it's a low level language, so you can't accomplish as much. So it's like 10 lines of things that almost do nothing. So you don't have this complexity of like moving between rooms and stuff. It's just, you appreciate our high level languages today and what they can do, because of what a low level language can accomplish is not that much.
What language is 325?
Assembly language. I don't know if we're going to use, we'll probably use ARM. We'll use ARM or MIPS, one of the two, but it doesn't matter.
Thank you.
Yep. What am I doing? Oh, let me give me a second so I don't.